Welcome to 15 minutes on 3.1 notes, vocab, and practice. Actually, I think I say vocab, notes, and practice usually. This section is on functions and relations to a little bit. Terminology, important terminology. I would look at the book starting on page 104, which you see mentioned over here. There's more detail in there, more examples to look at. I highly recommend doing that, especially when we're going through these notes. First off, we have a relation pairs inputs and outputs. Color coordinated here, inputs x coordinates, outputs y coordinates. This is written as our ordered pair x comma y. And this is actually supposed to be left blank and filled in. I can write better than that. I have that set for next year at least. A function. So it's a special type of relation. Each input x has exactly one output. So x can only go to one number. We'll talk about this a little bit later. This is one of the key points in key questions. Are simple. It can be a simple question to answer. It doesn't require computation. It's more of recognition of a situation. Domain is all possible inputs. I should probably do a small I there. But domain, all possible inputs. So the domain is the inputs. Those are your x values. The range, well, if this is inputs, what's left? Think about it. Pause it. You got it right. That's outputs. All possible outputs are y values on there. Independent variable, x. That can be x right there. Can be any value in our domain. So the independent variable is always the x variable. The dependent variable is always the y variable. Okay? It must be the exact value associated with x, or it depends on x. We know we find x, we can find y. We can work it backwards, but x is over the one we have control over. So if it's raining, a quarter inch an hour, the independent variable would be hours. The dependent variable would be how much rain we received over those hours. It's dependent on the number of hours. Okay. Notes is the relation of function. This one, notice we've got two inputs going to the same output, and that means absolutely nothing. That's perfectly fine. The multiple inputs can go to the same output. Is this relation of function? Yes, it is. Everything's fine. This one over here, I got 3 going to 7, and I got 3 going to 11, so I have these two 3s. That makes it a no. It is not. So that would be 3 goes to 2 numbers. Over here, y, each input only has one output. I didn't write that very well, sorry. But again, each input only has one output. Here, my input 3 has two outputs. 3's going to 7, 3's going to 11. This is not a function. So the no means not a function. The yes means it is a function. Okay, always lots of good stuff on these core concepts page and notes. A lot of it answers the previous page. This vertical line test, this is another way to tell if a graph represents a function. So when no vertical line passes through the function more than once. So they just show one here, but any vertical line I put on here, none of these hit it twice. So it's not just one, it's any one you put in there hits it twice, then it's not a function. So over here you can see this line they dashed in, but I could put another line here. You can see it hits it twice. Okay, not a function. So that's the vertical line test. Works nice with graphs. I mentioned what I said here. Each x listed only once. So 1, 2, 3, 4, 5, 6. Each x is only once. We're going to be good. Over here, we got the 5 listed twice. You got the 5 there. You got the 5 there. That makes that not a function. Okay. Domain and range, we mentioned these earlier. This is the classic diagram for it, the function machine. The independent variable x goes in on the left side. The dependent variable, or y, comes out on the right side. Some notes here. We want to see how changes in x affect changes in y. Changes, delta x, delta y. The delta, or the triangle, that's the Greek letter D, stands for change. Now, you've heard this word most of your life, slope. New term coming into play is rate of change. M is the letter that stands for slope. Change in y over change in x, that's just your y2 minus y1 over x2 minus x1 formula that you might have seen. Y2 minus y1 is a change in y. X2 minus x1 is a change in x. But this rate of change, that's a big thing when you hear rate of change. They're just asking you for the slope. It's not a new skill. It's a new title for a skill most of you know. So again, we've got vertical line test. I mentioned each x only listed once. If it's listed twice and it goes to two different numbers, it's not a function. Did we have anything else in here? Like the arrow thing too. So the arrow, like if 7 was going to two numbers, that wouldn't be a function. So we come down here. We got to do, there we are. So I'm not going to do all of these. I don't have all the answers on this page. Okay, I just threw these answers in here. They're not on the outline that I printed before. So that you may want to just note that. So you just got to complete these. So I put them down for the ones I'm not going to answer. Actually, I got them down for all of them here. No, I don't. I've got another one here. So let's do was going to do number 3. I'm going to do number 4 now. I don't have the answers for this one down. I don't feel like writing them. And then I'll do this one over here. I'm switching, pulling a change here. So this one, number 4, my domain is my x values. Here are my x. So this is kind of hard to see, but this keeps getting wider and wider. So on this one, the domain is going to be all real numbers. It keeps getting wider and wider. It gets taller quicker, but it's getting wider and wider too. It's not going to stop. The range a couple of ways you could say this. All non-negative numbers or 0 to positive infinity. Okay, because it keeps on going up and up and up. Over here, I got the domain started. We'll finish this one off. So you're going to have to do number 3. That's just the way it worked out. So my domain is x. I got 0, 1, and 2 there. Well, you can see I got 1 here at 3, 4, and 5. And if, I'm just looking down here to the x values on all those. The range, that's my y values. I got 3 and 4. And that's it. So that was my 3, 4, 5. There's my other 4. This one I didn't have answered. This one you got to answer. I don't have that one in the answer key. Sorry, the answer key's not working out here today. Sorry about that. I got to make a note for that for the future. So this one, my domain, again, x values. So I come down here, It's going from -3 to 3. I got the solid circle, so it includes those points, -3 to 3. The range, 0 up to 3. So that's 0 to 3. And the inclusive means that it includes the 0 and the 3 in those. Those are part of the set of answers. Number 7. Y equals 12x represents the number y of pages of text a computer can print in x minutes. So I've identified the dependent variable. You're going to do the independent variable. So you got to state the variable and what it means. So for the dependent variable, that's y. That's the number of pages that it can print. And I got that from right there, that part I underlined up there. And so you've got to get the x and what does it represent? Okay. Part B, they tell us the domain is 1, 2, 3, and 4. So y equals 12x. Well, if I put in 1 for x, 12 times 1 is 12. I put in 2 for x, 12 times 2 is 24. Just looking at those right there. So my range is 12, 24. You've got to do the 3 and the 4, see what you come out with. And those are going to be the numbers of the range. The x is the input, the y is the range, and we are done.